Hi, Michelle. This is in response to your question about ratios of partitioning line segments. So this is a lesson that I used to do back when we did not use MathNation. Directed line segment, same thing as partitioning a line segment. Given the directed line segment of AB, determine point P so that it divides the segment into a ratio of 1:3. So they're giving us the ratio, and it has 1 part to 3 parts, so it has a total of 4 parts. If we were to find the scale factor from here, we would say the scale factor would be, sorry about that, would be 1 part out of a total of 4 parts. So looking at the next one, the scale factor here, the ratio is 3 to 1, so 3 parts to 1 part. The scale factor would be would be 3 out of 4. I think you're getting the idea. The next one, A to B, would be 1 part to 2 parts, or 1 out of 3 for a scale factor. And the next one would also be out of 3 total parts, but this time the scale factor would be 2 to 3. So here's a couple practice ones, and I want you to make sure that you're paying attention to the fact that this is B to A. This is why this lesson calls it a directed line segment. It gives you the direction that it's going in. So we have 2 parts right here, so 2 to 3. Scale factor 2/5. Here 1 to 1, scale factor would be 1/2. Here we have B to A, so this is 1. Over here, 5 parts, so 1 to 5, and your scale factor would be 1/6. Okay, I wanted to do a couple more with you. Darn it, I didn't scan everything. Oh, yes, I did. Okay, good. All right, so I wanted to go over these with you so we could make sure that we could see the ratio as well as scale factor. So determine point P that partitions the directed line segment AB into a ratio of 1 to 2. Our scale factor here would be 1 out of 3. Number 2, look at it really quickly. What would your scale factor be? 3/4. What would your scale factor be on number 3? 2/5. And your scale factor on number 4? 4/9. And then the last one would be a scale factor of 1/4. So when they're giving you the ratio, they're giving you part to part, and you need to find part to whole. So here's our formula, and I feel like I would be remiss if I didn't go over the formula. You didn't ask for that, but just want to make sure you can do it, because it's the same thing for dilating a line segment or doing a dilation as well. So partitioning a line segment and doing your dilations, this is going to help. So the very first thing we do is find our initial point, and it's always going to be the first one given, 10, -3. Dilations are all about extending your slopes. So the main thing to remember with this, make sure you're doing the slope formula in this format, not y1 minus y2, because it's not actually looking at the slope, or not calculating the slope per se. It's looking at the individual slopes, if that makes any sense. So here, if I did 22 minus a -3, I'm going to get 25, and 5 minus 10 will give me a -5. My run is the denominator, my rise is the numerator, and I already did my scale factor of 2/5. So when I put that into the formula that's down at the bottom of this page, my initial point is 10. I'm going to add the scale factor times the run. Forgot where I was. Okay, take my initial point plus the scale factor times the rise of 25. And that's going to give me a partitioned point that is 2/5 of the way at 8,7. I hope that helps you. If you needed more than that, please let me know, but that's just what I gathered off of that email.